Cool. Welcome everybody. I'm Nam. I'm from Hyperlane, and I'm here to talk about economic security for permissionless interoperability. So, as you may have heard, either today or the last couple of weeks and months, we have a scaling problem. The gas is too damn high. If you've, especially actually, like I think 2 days ago, like gas prices spiked up to like 120 gwei again. And like, yeah, maybe a bull market, but maybe mostly an indication that, yeah, block space on Ethereum is still too expensive. And I think for years now, we've talked about rollups being the scaling solution. And we're starting to finally actually see that happen, right? Like many of my previous presenters have kind of like shared insights into the growth of rollups. And we think that that's just the beginning. 2 weeks ago, Celestia, right, like launched the first alt-DA, and many more are coming, right? EigenDA, Near just recently announced their DA layer, and so it's clear that the excitement about rollups as kind of the dominant scaling strategy are coming to fruition. And not only will we see kind of these like more modular kind of blockchain pieces like DA or execution come about, but there's also many different, like execution environments, many rollup frameworks. And so there's no question to me, to us here at Hyperlane, that, there will be a world of like 10,000 rollups. And I think, really cool, we'll get much cheaper block space all around at we don't have to sacrifice security, but the question becomes, how do we get interoperability in this kind of world of 10,000 rollups, right? Like in a world where all the applications were on Ethereum, we had this kind of shared state where we could have composability. But what do we do in a world of 10,000 rollups? And so in our opinion, the solution has to be permissionless interoperability. It cannot be interoperability that is gate-kept by central bridge providers who you have to beg to connect your rollup to the rest of the ecosystem. And so the way we do it, Hyperlane, the way it works at a very high level is that on the origin chain, the sending contract calls the mailbox. And then on the destination chain, the mailbox will basically kind of call the receiving contract, but it's checked by what we call an interchain security module. And in Hyperlane, we modularize the security module away from the messaging interface. And that is basically allows different security modules to apply between two arbitrary chains. Right, like what makes Hyperlane different from virtually any other interoperability protocol outside of IBC is that there's no canonical security model. And so chains, applications can effectively choose their own validator set, who basically observe the origin chain mailbox state, effectively do an attestation to the state root on the origin chain, and that's what's being used on the destination chain to process a message. And so like I mentioned, like modular security, this kind of like modularization is key in enabling permissionless interoperability. And it also allows developers to basically like only implement the single messaging interface and then upgrade into better security models as they become available. Right? Like that not only means like larger sets, right? Like as your rollup becomes kind of like more important, but also means like the use of the native rollup bridge itself, or very excitingly, ZK-like clients that several teams are working on. And so that kind of gives, again, as I said, these rollups, this kind of like future-proofness that they don't get when they currently pick a single bridge, right? Like once you pick a bridge, once your token selects a representation, you're kind of like stuck in it. One thing that we're very excited about is that the Hyperlane protocol is fraud-provable on the origin chain. And so let's say if you want to send a message from the rollup down to the layer 1, you can actually have the stake live on the rollup, and then if a validator, let's say, lied about a particular state on the rollup, their stake gets slashed on the rollup. However, a problem with that is that if there's, again, this world of 10,000 rollups, you as a validator will need your stake segregated among 10,000 rollups, and that obviously means that the individual security of each message from each rollup is going to be relatively small. However, like a really cool construction that we're excited about is basically you can have the stake actually live on L1, like let's say live on Ethereum, and then when the validator lies about L2 state, the slashing condition actually gets communicated via the native rollup bridge, and so that allows you to keep the stake on L1, and not only that, but it also allows you to reuse the stake across many different rollups. And obviously this is where EigenLayer comes in, because you can not only use arbitrary tokens on Ethereum, but you can use restaked EigenLayer ETH. And that dramatically lowers the cost of capital for these validators to basically provide attestations onto these rollups and replicate this many, many times across all these rollups. And so we believe that this will be a very attractive option for operators to basically get exposure to all of these rollups without really having to invest a lot of operational, diversity to their infrastructure. And so, yeah, more points, I guess, on the operational readiness. So our validators are all open source. It's Prometheus metrics and Grafana dashboards. Like, we've been in operation for more than a year. There's no double signing considerations, so like you can easily replicate for liveness reasons. Yeah, there's been virtually no incidents. Like the validators we've been running with today basically generally tell us that it's the easiest validator to ever run. I'll just quickly show you our GCP dashboard, and yeah, like I think both the CPU and memory considerations here are so minimal that usually you can run several validators on like the smallest AWS machine. And then maybe as a live demo, because who doesn't like live demos, all you have to run is this single Docker image. You basically tell it what origin chain, which chain you want to validate for. You give it a particular key where you want to write your checkpoints, and then you go, and that's it. And so, yeah, we think from an operational perspective, it really couldn't be simpler. And honestly, it's been one of our biggest challenges to convey to people that, like, sure, this is a validator, but it's not a validator like kind of like you're used to. And again, very easily replicatable. What else do I have here? Yeah, so in terms of like, I think the remaining work on our EigenLayer integration, like our fraud proofs already implemented. So really like the only remaining thing that we have to do is actually like integrate it into an AVS smart contract. But like I mentioned, I think operational and risk concerns are so minimal that we think it's going to be very attractive. For us as a team, we've been around since 2017. We've built actually like we've been involved in building Celo, another layer 1 blockchain, and know how hard it is to run an actual layer 1 blockchain validator. And yeah, this is some of our background and fundraising history, and yeah, very excited again about this world where we will have very abundant block space all around, and we hope that Hyperlane can play its part in connecting all of these rollups together. Here's our list of docs and contact info, and yeah, if you have any questions, you can catch me outside or reach out to us on here. And I think that's it. Thank you, guys.